guys, good morning all. Just give me the chat if you guys can hear me and see the sublime text. Quickly give me the chat if all of you guys can hear me and see sublime text. All of you can. Cool. Let's quickly start with today's session. Before starting today's session, let's have a quick revision what you have done till the last class, and then we'll start with today's session. So last class on 6th of July, we started with the very first class of dynamic programming. We'll continue the dynamic programming and probably will move on to some questions as well. Okay. All right, having a quick revision, what we discussed in the last class, we're finishing up some questions based upon hashing. So start with question number 3, which is find the difference. What is the question about? You're given two strings S and T. String T generated by randomly shuffling string S and adding one more character. So you need to find out what is that one more character. Now, obviously, duplicate can exist. So obviously, hashtag is not a right choice here. We talked about multiple solutions to this problem. Number one being brute force. So what I can do is I can use two nested loop. I can compare each character at every time and I can compare whether it's present or not. Big of n square space big of 1. Second is I can do sorting and two pointers. Once I sort both the strings, if whatever the extra character is, I can just use two pointers and I can see whichever is not matching. Time complexity is going to be a combination of sorting both the strings. Third, we talked about map-based approach. So what I can do is I can count for each character and I can compare map. So for that, I can use two maps or I can use one map also. If I'm using one map, in that case, I'll be incrementing the frequency in first string and decrementing the frequency in second string. And that way I will be able to tell that. For whatever key frequency is not equal to 0, that is going to be my output. I'll return that key. Time constant big of n plus big of n, which is big of m plus n technically, which is 2 times big of n because there's only one character which is different. Space comedy big of 26. Same approach you can do for frequency array, two frequency array, one frequency array. You can do XOR in one pass, two pass, or you can do XOR in one pass. What is XOR in one pass approach? Since there's only one extra character, we know the property of XOR, which is that if you take a XOR of a character or a number with itself, the output is 0. So whichever value which is present, the XOR will become 0, and the last ultimate XOR output will be the only character which is extra. Okay. Then we talked about two more solution, which is sum of ASCII characters. Now, sum of ASCII characters, in this case, my length is given only up to 1000. So I don't need to worry about integer or float, such cases. If I talk about maximum sum and where the intuition come from, let's say if it's given as digits, right? If it was given as digits, I probably would have taken like 1, 2, 3, 1, 2, 3, 4. I'll take the sum, I'll find out the common digit. I can extend the same approach to string. In terms of extended to string, it's just that my character would be mapped to a number via ASCII character value. Okay, so still I can get my answer. Now, in this case, since my constants are very small, I can still get the answer, which is going to be maximum of 122,000 within the range of integers. If, so time comes to big of n, space comes to big of 1. If the sum of ASCII characters with the range of value become 10 to the power 9, how I'm going to modify my solution? This will not fit within the range of integer, but if I have to modify my solution, how I can do that? I can do that via the modulus approach. So I can keep a value of up to 256, which is my ASCII limit, and any value will be within that 256 range. So time constant traversing both the strings, space comp big of 1. Then we move to question number 4, which is lead code 819, which is most common one. Now, this question has multiple substeps to it. It's not a difficult question, but it has multiple substeps to it. What are the multiple substeps? Number 1, basically what the question says is I'm given a string, and within that string, I need to find out the most common word. That word should not be present in an array, which I'm given as a band word, and it has to find the highest frequency. And on top of that, you need to make sure of some punctuation. For example, lowercase, uppercase should not matter, punctuation should not matter. So if you look at this, I can ignore the punctuations. So balls, comma would become as balls, or capital balls will become as balls. I need to ignore the extra character and spaces. I need to ignore the uppercase and lowercase. I need to check if the word is not banned, and then I need to find the most frequent word based upon count. Okay. So if you look at the solution part, number 1, I can convert my paragraph into array of string. So paragraph will become string array of words. I can remove the extra characters while I convert into array, right? How you can do it? You can do it using regex. You can use by split function, which is provided in Java. So regex, you can use it by stream functions, which is in Java 8, or however you want to implement it. You can write a custom function also. Second is, once I convert all string in my string array words to lowercase, why? Because my band array only contains the lowercase. So it makes much more sense that I can directly convert to lowercase. If you don't want to convert to lowercase, that is also fine. In that case, you can use the function dot equals in lowercase. Okay. And third, once you do the first two steps, now your question becomes pretty clear. You're given two string arrays, words and band. You need to find out that word which has the highest frequency in words and not present in the band. Okay. Now, if I have to look up in the band array, one thing is that I can look up in an array that makes my complexity big of n in the worst case, or if I make a set out of it, that makes my lookup into big of 1. So I can convert band array into set and look up in big of 1 because I probably need to look up for every word. So m number of words, look up n number of times will be m into n, but now it will be big of m into 1. Then I need to go to the highest frequency. I'll use a map. In my map, I'll keep a key of word value of frequency. So let's look at the code part. Pretty straightforward code. You create a set out of the Ben string, and once you've got a set out of it, then you create a hash map for finally keeping a count. This is where I'm using the regex here. What I'm doing here is I'm converting it to lowercase. I'm splitting by extra characters. Now, first thing word in words, big of n into 1 because I've used a hash set here. I'm populating in my map. After in my map, what I'm doing, I'm comparing by value. Whichever value has the highest maximum, I'm getting the key. Time comes to big of n, space comes to big of n, set plus 1. Okay. This is what we have completed in terms of the hashing. Then we start with a new topic, which we call as dynamic programming. In the beginning of the session, I told you something is once we are done with dynamic programming, which is usually after 3 classes. So take like by the end of next weekend, once we'll be done with that, we'll look back these numbers. So first I talk about how much comfortable or confident you feel in terms of solving DP questions. So on a scale of 1 to 10, I got the average to be 1 to 2, which is remarkably low. In terms of recursion, I got decent number, which is 5 to 6. As I said, the target would be to keep the DP to 8 to 9. I'm not committing 10 because it requires practice as well. Okay. But yeah, by the end of next weekend, once we're done with all the DP sessions, we'll revisit this number and see whether we're able to reach 8 to 9. First thing first, we started with understanding what is DP versus backtracking versus greedy. What's the difference between these three set of algorithms? DP is an optimization over recursion by storing the result of previous state. Why do we do that? Because we don't have to recalculate, or basically we want to optimize the time. Example of DPs include 01 knapsack, LCS, LIS, etc. Second is backtracking. Backtracking means optimization over recursion again, but without storing the state result. This time we are not storing any state result. The purpose of backtracking is to exhaust all possible solution. Example, retina maze, NP's problem, etc. And then finally, greedy. Greedy means find me the best solution now. Don't think about the future. Greedy has nothing to do with the recursion. Okay. Greedy claims local maxima or minimum is equal to global maximum minima. Explain that via the graph example also. Example of a greedy problem is coin chain problem. Then we move to DP versus greedy to understand the practical example first. Example, Goldman problem. So if you're given a matrix, each cell contains gold coins, you need to calculate maximum gold coins in the matrix. Okay. My constants given are I can travel to right or I can travel to down from my given position. So I have a source, I have a destination. From my current position, I can travel right or I can travel down. I need to talk about source to destination path. So if you look at it, the maximum number of gold coin that I can collect is via the path 100,000, 80, 90. Now, same problem statement, how it will be solved by DP, how to be solved by greedy, let's talk about it. The way DP is going to work is, DP will find all the source to destination valid path first, and then it will check for whichever is the maximum. Okay, so if you look at this is one path, second path, third, fourth, fifth, etc. So list down all the valid path and also count out which is not valid, and then pick the maximum value out of it. This is how DP will do. That's why it will always give you the accurate solutions. What greedy will do, let's try to understand that. What greedy will claim is that if you're currently at 1, you have only two options. Either you can go to 10 or you can go to 100. So greedy claims since 100 is greater than 10, always go to 100. Okay, so at every step, choose the best solution there. Don't think about future. That's the meaning of local maximum minimum equal to global maximum minimum. Now, greedy will not always give you correct answer because of this word always. So test case number 1, it gave you the correct answer, no worries. But test case number 2, again, greedy will make the same choice. It will prefer to go to 100 instead of going to 10. And if you do not go to 10, you will not be able to go to 2000 ever, right? That's why it will give you incorrect answers as well. That's the difference between, we'll talk about it, memorization and tabulation. We'll go to the questions, we'll see about it. Okay. More or less, it's more about a recursion. There are two kinds of recursion. One is a tail end recursion, one is a head recursion. That's exactly what we call as memorization and tabulation, top down or bottom up. Okay. We'll discuss all of those things. Now, coming to DP specifically, this is what we have a broad classification of understanding what is DP versus greedy versus backtracking, then understanding with example how DP works or greedy works. Now we finally move our focus to DP. So as I say, if you want to become master in any DS algo, know three things about it. What is the real life application, or what is the use case problem it's solving? What is real life application? How it is coded and implemented? So first thing first, what exactly is DP? DP is nothing. It's an optimization over recursion by storing the state results. So same thing which recursion is doing, DP is also doing, but in a better optimized way. Now, optimization can be two things. Either it can be in terms of time or it can be in terms of space. Now, when you look at the second word, storing the state results means I'm definitely not optimizing space. I'm using space to optimize I'm using space to store something, but I'm optimizing over time. Why do we do that? As I said, we are reducing the exponential time complexity to the polynomial time complexity. Example we see in the recursion code. Fibonacci recursion is 2 raised to power n. DP recursion is DP of code is Fibonacci of DP code is big of n. And 2 raised to power n to big of n is a very, very big optimizations. Then we talked about state variables. What is state variable? These are the number of variables which determines my order of DP. What do you mean by order of DP? Whether my DP is a 1D DP, 2D DP, 3 DP. What are these dimensions in the DP? The dimensions denotes about how many state variables are involved for your state. So if your state depends upon only one variable, you call it as 1D DP. If your state depends on two variables, you call it as 2D DP. If your state depends on three variables, you call it 3D DP. K variables, KD DP. Okay. Example of 1D DP includes Fibonacci, 2D DP includes 0, 1 knapsack, 3D DP includes House of Robbers 3. Okay. Then we move to the part of Fibonacci sequence. So in terms of Fibonacci sequence, let's take an example. The idea of Fibonacci sequence is the nth term is the sum of the previous two terms. So n minus 1 plus n minus 2. What do you mean by that is, so we define base cases also. Fibonacci of 0 is counted as 1, Fibonacci of 1 is counted as 1. So if I put n equal to 5, my expected output is 3. Now, if I put n equal to 5 here, I'm expecting an output of 3. But if I put it in this recurrence relation, I will get is fib of 5 equal to fib of 4 plus fib of 3. 4 will be 3 plus 2, 3 will be 2 plus 1, etc. etc. Right? If you look in terms of a tree diagram, this is how it looks like. 5 goes to 4, 3, 4 goes to 3, 2, 3 goes to 2, 1, 1, 0, etc. So what is technically happening is every time it is redirecting you to go to the leaf node and travel back to the current node that you talked about. If I have to calculate 4, I'll go to 3, 2, 1, 0. If I have to calculate 5, I'll again go 5, 4, 3, 2, 1, 0. Any value that you want to calculate, you have to go back to the leaf node. Okay. And that's exactly what DP has solved. So I explained you with a real life example to understand. For example, if let's say these are the building towers and these are the different floors in a building. And if you have to collect, there are two brothers, Recursion and DP. And if you have to collect the secret center from every floor and every neighbor in there, how will you calculate it? How Recursion will do it? Being a hard worker, it will always start from the ground floor. 0, 1, 0, 1, 2, 0, 1, 2, 3, 0, 1, 2, 3, 4. Basically, every time travel from the leaf node to that root node. If you're a DP, you'll go for a smart worker. Means if you have come to already a state of 4, let's say, so you have already traveled 0, 1, 2, 3, and 4. So if you have already traveled till 4, why not store the result? If I travel 3, I got the answer, store the result. I got 2, store the results. Next time when I have to go to 4, I don't need to start 3, 2, 1, 0 again. I can take the result which is stored at 3 and stored at 2 and just add it. Similarly, if I have to calculate for 5, I don't need to go back to 1 and 0 or the leaf node again. I can store the result at 4, I can store the result at 3, I can get my answer. Okay, that's exactly what DP does. We talked in terms of the code for that. So this is a recursive solution. If you can look, these are the base condition and we are recurring every time on the base conditions. Okay. Complexity of recursion is branches raised to the power depth. So there are two branches, 2 raised to the power n, space comp big of n in terms of auxiliary memory. Now, in terms of a DP solution, if you look at it, here I'm storing my state results. So in terms of my state result, I define result of 0 equal to 0, result of 1 equal to 1. So I equal to 2, I less than equal to n. Here I'm storing the state result in this array. That's why if I have to calculate for n Fibonacci, I can just return result of n. Time comes to big of n, space comes to big of n. Now, this is a very, very big optimization when you're able to reduce from, yeah, we sacrifice on the space for sure. If you talk about this is big of one space in memory, but auxiliary memory is always there. But in terms of time, I've got a very big optimization. This is something that we have discussed in the last class. Quickly give me clear if everybody is still clear, so we can start with today's session. Come on guys, quick in the chat. DP solution is not recursive. DP solution is not recursive. Is that a question or answer? I didn't get this. DP is the alternative way to make recursion. Alternative solution apart from recursion. Okay. Find the difference question. Can you please add so or base solution to today's notes? Okay. I mean, it's a pretty straightforward code, right? Just take a XOR of all the values. But okay, I'll implement it after the session. And before I move here, are you guys okay to extend the session by few in the sense 15, 20 minutes? If anybody is not okay, let me know. Accordingly, I'll practice things. Guys, if anybody is not okay, just call it out. I'm assuming that everybody would be okay. I mean, in the sense of those who are not replying. But the point is, those who are not okay, please call it out. If somebody has some other commitments, please let me know in advance. Okay, I'll update the next batch then. Give me one moment. Okay, I'll update the team for accordingly. The reason I'm saying is for our DSA session, I think it has been extended quite a lot. Ideally, it should be finished within 6 months, and it does happen within 6 months. It's just that when we started, there was time when I was on vacation, and I believe some other instructor took some sessions, but it didn't work out precisely. So I have to retake all the sessions and everything, right? So we lost around 1 month there because technically there was no sessions on that 1 month or whatever the session didn't work out. And then we have to I have to travel quite a lot between different countries. So it happened. So, but the way I'm prioritizing, we are pretty much at DP now. So backtracking, greedy, trees, graph. We don't have much topic left, but I also want to finish it by hopefully by July end, and if not by August mid, right? I don't want to extend too much for this course. Cool, guys. That being said, let's finish up this and then we'll move on to next. So one part to add here is the optimization that we have done from big of 2 raised to power n to big of n. Let's try to understand it. That's why I'm adding it in the previous note. Nothing too much here. I will start with the new note here. If you take n equal to 100, for example, your one iteration takes 1 second. Assuming that your one iteration takes 1 second, even if you talk about n equal to 100, if I talk about calculating 100th Fibonacci number, if I write it in recursion, system design tentatively, it depends whether it's a high level design or low level design. High level design are usually more because there are more number of case studies. So high level design take around 3.5 months, and low level design usually 2 months because there's a 3 case studies only. Okay. So big of 2 raised to the power n, when we talk about it, that will be 2 raised to the power 100 iterations. Okay. Which means 2 raised to the power 100 seconds to execute. And when we talk about big of n, that is going to be only 100 iterations, which is going to be 100 seconds, which is 1 minute 40 seconds. Okay. Now, just a moment to take a pause here. Anybody can guess how big the number 2 raised to the power 100 is? Any random guess? 2 raised to the power 10 is 1024 for your reference. Come on, guys, quick in the chat. Anybody wants to test their mathematical skills? I'll wait for 5 more seconds if anybody want to try. No chat GPT answer, guys. I don't need the exact number, just make a rough assumption. What would that be? All right, let's look at this. 2 raised to the power 100 is going to be petabillions. Petabillions means trillions and trillions of years. So if you write a recursive code where one iteration take 1 second, the moment you will get the 100 Fibonacci number, pretty much everything would have been already. I don't think there would be earth by that time, but yeah, you will never be able to see the answer for sure. Okay. On the same side, if you run the DP code, it will take you 1 minute 40 seconds, provided one iteration take 1 second. That's the significant difference you can see with just n equal to 100. Imagine if it was 1 million or 1 billion, that will see for the difference. So revisiting DP, what exactly DP does? DP stores the results of previous subproblems. Why does it do that? So that it can be used again. Okay. There is no need to recalculate again and again. That's it. Okay. This is something that we discussed in the last session. Now we start with today's session part. Okay. All right. Somebody asked a question for recursion questions to be taken, lead code medium level. We can take it. Just remind me after once we're done with this topic. Anyways, I usually keep like 1 or 2 extra sessions in terms of anything which you want to discuss once our DSA course is done. Now, coming back to it, now we are going to move to the crux of the DP session, or the most important part of the DP session. What is that? That is how to solve any DP question in the world. Okay. This is the most important part of entire DP sessions, 3 DP sessions. So first thing first, I want all of you to focus your complete attention here, because I've seen a lot of people, they are very, maybe afraid is not the right term, but they're very not confident or nervous while solving DP questions. See, everything in DSA, I mean, I'm talking about DSA, I'm not talking about competitive programming in general. Everything in DSA has a pattern about it. All you have to do is you have to understand the root cause and you have to understand the pattern. Once you're clear with that, question would become straightforward. Okay. And once you start noticing pattern among the question, you can solve any question in any way. Okay. There can be multiple ways you can solve the same question. What this is about it we're going to talk about a template. And using this template, if you apply it properly, you would be able to solve any DP question in the world. And I'm not saying DP can be the only answer for it. It might also be solved by some other, maybe it can be solved by backtracking, maybe it can be solved by gradient, etc. But at least you'll be able to have this complete template that how if I have to solve by DP, how exactly I will solve by DP. Okay. This requires 4 steps. We'll go to the 4 steps one by one. Then I'll take one or two, three questions just to make sure you guys are comfortable with it. Once that is done, then I will leave up to you to implement the template. That being said, it's not mandatory that you use the template every time in any DP question you're using. If you feel confident enough, you can do without template, feel free to do that. But if you're ever stuck, stick to the template and it will guide you in the right way. Okay. All right, guys. So let's start with this. There are simple 4 steps that you have to solve any DP problem in the world. And when I say any DP, I'm talking about any dimensions of DP. It's 1D DP, 2D DP, 3D DP, 4D DP, doesn't matter. First thing first is you need to identify whether that question is actually a DP question. Do not try to put a question or make a question a DP problem. This is something I think the most critical part. I see a lot of people, they try to unnecessarily make a question a DP problem. Every question is not a DP problem. There are very specific set of questions which can be solved by DP and they will be solved by DP, right? That being said, there can be question which can be solved by DP plus some other algorithms as well. Okay. So the first important part is you identify whether the question needs to be solved by DP or not. The question itself will tell you whether it needs to be solved by DP or not. Now, how do you identify that? The trick is look at the keywords. The keywords will tell you whether that can be solved by DP or not. And you probably would have noticed it in case you know someone who is very good at programming or programming in the sense very good at competitive programming or something. They can look at the problem statement and they can say this is a DP problem. While you might be figuring out why exactly is a DP problem or what makes it a DP problem. So the answer to that is observe the keywords. The keywords will tell you whether it can be solved by DP or cannot be solved by DP. Example, look at the keywords like maximum, minimum, largest, smallest, longest, shortest, count, number of waves, permutations, etc. etc. Okay. Wherever you feel any sort of mathematical operation is happening, and instead of mathematical operation, whenever you feel like I need to get all the data, and then out of all the data, I need to select one value, which is maximum, minimum, smallest, largest, keep a count, etc. All of those are DP based problems. Okay. Let's try to understand with an example. How many of you have solved this problem before? Longest common subsequence, commonly called LCS, between two strings. Anybody has solved this problem before? If you have not solved it, have you heard about this problem before? If you have not solved it, at least you would have heard about it. It's a very common problem statement, LCS or LIS. LCS is longest common subsequence, LIS longest increasing subsequence or substring, whatever it is. These are very common problem statements. Even if you have solved it or not solved it, can you look at the problem statement now and tell me if there is a keyword which tells you it can be solved by DP? What is that keyword? All right, guys. Irrespective you have solved this problem or not, now if you have understood the trick, you can filter out that this keyword tells me that this question can be solved by DP. Okay. Now, that being said, those who have solved this problem statement, they would know that this is actually solved by DP. Those who have not solved this, you can search on Google LCS DP solution. You will find a lot of articles for that. Okay. Now, there is one part to it. This is the trick part. I can tell you the reasoning behind it if you're interested. If you're not interested, I can move to second part. Whatever you guys want me to do. These keywords are sort of relational to being able to break down into smaller nodes. That's what I'm coming to. So, okay, let's step by step, guys. This is the trick. How do you identify a question can be solved by DP or not? Okay. I can move on to the second step, or I can tell you the reasoning behind it, whatever you guys want me to do. All right. If you want to do, let's talk about the reasoning as well. Everything in programming and mathematics has a reasoning behind it. Okay. The reasoning of that is where we started from. Let's go back to the beginning. Here. If you guys remember, the DP way of solving problem is we find all the valid solutions and then select the best solution. Okay. If you remember when I told about the DP way of solving problem and the GD way of solving problem, that's where we discussed. The way DP works, it will find all the valid solution and then it will select what is the best solution available. Example, if I talk about array 1, 4, 2, 3, and if I ask you, find me the maximum element in the array, what will be the output? You will say the output is 4. In order to get the maximum output as 4, what you would have done is you would have compared the value across all array or every element in the array, and then you would have come up to the decision. Now the maximum element is 4. Okay. So you check for all values. That is when you come to the decision maximum value is 4. All agree with this? Come on, guys, quick in the chat. Cool. There's a detailed article on it. Let me share that lead code link. If you want to read about it, I can share it. Let me quickly find that in the chat. I hope they still have that article available. Let's see. I did publish in 2019, so I'm not sure if they still have it. Yeah, they still have it. All right, let me log in real quick. All right. I hope everybody can see my lead code screen. Just let me know in the chat. Okay. So I contributed to some of these articles. The first two articles I contributed to, you can read about it. That's long article from 2019. But this is technically what I told about. What is DP? How does it DP works like? Top-down approach, bottom-up approach. That somebody was asking tabulation, memoization. Everything is listed here. But what I'm more focused is when to use the DP part, right? So when we talk about when to use DP, this is what I was talking about: maximum, minimum, ways, longest, etc. This is the characteristic part of where you can talk about DP. This is the reasoning behind it. If you want, I can share this link. Feel free to refer whenever you are revising with the notes part. Okay. This is the reasoning behind it. And I'm putting that link in the chat as well. Okay. All right, moving on. So first thing first, we talked about how do we identify whether the problem can be solved by DP or not. That is step number one. Once you have clearly identified the problem can be solved by step number one, which is it can be solved by DP, now you move to second step. Second step is decide a state expression. Okay. What do you mean by state expression? State expression means in my dynamic programming, everything is a state. I'm traveling in different states. I'm trying to get the answer. I'm trying to save the answer for different state, right? So when I say decide a state expression means at any random state of K, what exactly I'm looking for. Okay. And that is always mentioned in the question. Whatever you're looking for, it's always mentioned in the question. Let me add a note here. State of N is always mentioned in the question. Okay. All you need to do is For state of k, just replace n with k. That's all you need. Okay. This is for deciding a state expression. Third is formulate a state relation. This is the most important part of DP. Step number 3 is the most important part. Okay. What do you mean by formulating a state relation? How does the current state result relates to previous results? How does the current state result relates to the previous result? For example, if I'm at state of k, how did I exactly reach at state of k? Did I reach it from k minus 1, k minus 2, etc., wherever I've reached it from? And then there is a step 4 also, which is optimization. Either you solve it by tabulation or you do it by memorization. 90% of the problems you'll be solving by tabulation, by the way. Okay, top-down approach. And bottom-up, which is memorization, you'll be solving by 10%. This is usually for higher order DP, 2D and above. Okay. So my tabulation is top-down approach. Memorization is bottom-up approach. Okay. All right. That being said, there's some of the steps which would be not clear to you and which is completely fine. This is a template. This is not exactly a question. We'll understand how to implement this template via question. So before we move to that, let's again quickly revise because this is the most important part. And for 10 or 12 questions we'll be solving in DP, we'll be referring to this template. If you feel confident enough, again, feel free to leave the template. This is not a permanent template to solve. This is something that I have built with or I have come up with. Feel free to make changes. Feel free to move things around if you want to. This is something which is easy to implement and it's easier for everyone to understand as well. That's why I've implemented it. You will not find this documented anywhere unless I have posted on any of the articles, which I might have or might not have. Okay. Anyways, coming back to this. To solve any DP question in the world, you need to follow 4 steps. First step is to identify whether the question can be solved by DP or cannot be solved by DP. How do you identify that? You look at the keywords. Wherever the keyword gives you a trigger or where the keywords gives you a sensation that I need to find all the solution, then I need to select pick the best one. That is the DP problem statement. Okay, or it can be solved by DP. So where I have to calculate maximum, minimum, longest, count the ways, you need to know all the ways to do all that, right? That's why it's called DP. The reasoning behind it, I already explained. The way DP works, it finds first all the valid solution and then it select the best solution. Detailed theory I have provided you here. Once you have confirmed it can be solved by DP, then you move to step number 2, which is deciding a state expression. What exactly is a state expression? State expression means at current state of K, what is that am I looking for? State of n is always mentioned in the question. All you need to do is replace n with k. Number 3, which is the most important part of DP, is you formulate a state relation. If you are at a random state of k, how did you reach at a state of k? Did you reach from k minus 1, k minus 2, wherever you reached to? How does your current state relates to the previous results or previous state results? Fourth is the optimization in terms of tabulation and memorization. So higher order DP, which is 2D and above, it will take care of the optimization. Okay. Now we have a list of questions that we have to solve for. So I'll take this problem statement and then we'll start solving it. Okay. I'll remove the done part because we have not done any of this question yet. What we're going to do is we're going to take this problem statement. I'll take the 2D also. These are the list of questions we'll be solving. What we're going to do is we're going to solve these questions one by one and many more questions apart from this. And while we solve these questions, we'll be implementing this template. Okay, and let's try to see how we'll be getting our answer. So let's start with question number 1. Question number 1, which has been asked in Amazon. Maximum steps to reach an ad state. Okay. Same question is available on lead code as well. I'll take you to the lead code part if you want to solve there. But before that, let me give the question exactly what Amazon asked, and then I can take on the lead code version of it. Remember, companies will not ask you the exact question. Companies will ask you a variation of it. This one is pretty much an exact. Okay. Test cases might differ. So let me find that problem statement quickly for you. Okay, so this is here. All right, I got the problem statement for you. There you go. This is the exact problem statement as asked in the online assessment. So take some time to understand the problem statement, then I'll move on to the next part, which is understanding. The problem says there are n stairs. A person standing at the bottom wants to reach the top. The person can climb either one stair or two stairs at a time. Count the number of ways the person can reach the top. Order does matter. Then they've given some example input, which is 4. Example output is given as 5. Please output your answer as modulo of 10 is to the power 9 plus 7. This is the only different part which is not there on lead code. Okay. Let's understand first. A lot of terms here. We'll go about the example and everything, but I want to understand this word specifically. Order does matter. Can anyone explain me what does order does matter mean? Based upon your understanding of the problem statement, what does order does matter mean? Bottom to top. Okay. So in the problem statement, they never say bottom to top. They said wants to reach the top. Person is already at bottom, wants to reach the top. What does this statement means? The person count the number of ways the person can reach the top. Order does matter. What does that mean? He cannot come back. Okay. Can't go up and come down. Nothing about that is mentioned. Anything else? Oh, it is not that complicated. Cool. Coming back to it. See, understand. What you're allowed to take only one stair or two stairs at a time. Correct? What does that mean is when you say order does matter, means if you take one step first and then you take two steps, versus if you take two steps first, then you take one step, these are counted as different solutions or different ways. So my count would become 2 for this. This part clear to all? That is what you mean by order does matter. If the question was order does not matter, in that case, whether you take 1, 2 or 2, 1, they'll be counted as same solution, then you'll be counting it as 1. Everyone clear with this first? This is what order means. The way order in which you're taking one step or two step, it matters. Okay, repeating it again. There are only two ways you can travel. Either you can take one stair or you can take two steps. Agree? When you say order does matter, means if you take one step and then you take two steps versus if you take two steps and then you take one step, these are different solutions. So they will be counted as two different ways here. If my order doesn't matter, so whether you take first step and then you take second step, it won't matter. Okay. That was number one. Number two, now let's try to understand how does example input of 4 give me example output of 5. Let's talk about it. Example input, if I talk about n equal to 4, what are the ways in 4? The ways in 4 are 1, 1, 1, 1. I can travel all 1. 1, 2, 1. I can make 2, 1, 1. I can make 1, 1, 2. Or I can just do 2, 2. All agree? Is there any other way that I can move to 4? Is there any other way that I can move to 4 by taking 1 or 2 steps? No, these are all the ways. So output becomes 5. If you take total number of ways now, output becomes 5. The function that was given for implement was maximum underscore steps. It was given as integer n. Be rest clear, n is a number, returning an integer, and you have to take a modulus of 10 raised to the power 9 plus 7. Everybody crystal clear with the problem? Quick in the chat, guys. Any doubt in the requirement of the problem? Okay. Anybody who can guess which problem is this at this moment? Okay. Okay. Cool. We'll talk about it once we're done with the solution. Now, this is was the original question which was asked in the online assessment. One moment. This was the original question which was asked in the online assessment. I can share the lead code version. Let's solve the lead code version because that way, whatever approach you think of implementing, you can code and you can implement. I want to give you due time. Whatever approach you are thinking you can implement. But eventually, as I said, what are we going to do is we are going to stick to this template. We're going to implement the 3 or 4 steps depending upon the question, and we'll see how the template works. Okay. But that being said, I want to give you your time. If you want to try it, let's try it, and then I'll start with this. This is on lead code called as climbing stairs, lead code 70. Question number 1. Okay. Let me take you to that problem statement, and you guys are free to start coding and solving a problem. Then we'll take the template route. So let me share my screen real quick. There you go. Okay. This is lead code 70, climbing stairs. As you can look at some of the stats here, 8.1 million submission tells you how much important this problem is. 8.1 million people, 8.1 million submissions have already been made. 53.6% acceptance rate. And if you look at the companies which have asked this question, you can see majority of the companies have asked this question quite recently. Okay, 23.4 thousand likes. The question is, you're climbing a staircase. It takes n steps to reach the top. Each time you can climb either 1 or 2 steps. In how many distinct ways you can climb to the top? So n equal to 2, you can make 1 plus 1. N equal to 3, you can make 1, 1, 1, 1, 2, and 2, 1. N equal to 4, we will talk about the output as 5. Constraints are very small here. 1 to 45 only. Okay. In your actual interview, the constraint won't be that small, by the way. Cool. There's a reason these constraints are small. We'll talk about it later. But that being said, let me take you to lead code problem statement. So you all have due time to try that. Example 1, example 2, input output, input output. Okay. And constants. The function that you have to complete, let me give you that as well. You'll be completing this function. Public integer climb stairs. This function is taking an integer as input, returning an integer as an output. Okay. Now, that being said, guys, the problem statement has been explained to you. You guys are clear with the problem statement. You don't need to follow the template now. I would recommend you to solve this without template. However you think you can solve this question, go ahead, solve this question. Then when I will discuss, I will show you how to use the template and how do you solve the question by template. Okay. If you think you can solve this without template, please feel free to do it. And I would recommend that. However you want to do it. Then I'll start implementing why exactly it becomes a lead code, why exactly it becomes a DP question, and we'll follow the steps in the template. Okay. That being said, this is your problem statement. Pasting the link in the chat. This is the function that you have to implement. Feel free to code in any language of your choice. Don't take too much time for it because we have to solve a lot of questions today. But once you guys are done, just let me know in the chat. Okay. Please change your message directly to me. Do not message to everyone. Start solving this problem. Share the submission link. Do mention time and space complexity in the code. Once you guys are done, please call out in the chat that we are ready to discuss. Once we discuss, then we'll move on to the template part. Everybody crystal clear with the instructions? Okay. How it makes difference is if order does not matter. Order does matter, it's not making any difference. If order does not matter, let's say, in that case, I'll be counting 1, 2, 1 with 2, 1 as same. Because it doesn't matter whether I take the first step or I take the second step. That's what it means. Okay. All right. So in this case, if you look at this example, 1, 2, 1, 2, 1, 1, 1, 1, 2, they will be all counted as 1. Okay. So this will become 1 unique, this will become 1 unique, and this will become 1 unique. So your output will become 3 in that case. Anyways, coming back to it, guys. Everybody clear with the instructions? I've shared you the lead code problem. I shared you the function to complete. Cool. If everybody is good, your time starts now. Once you guys are done, just let me know. Please change the message directly to me. Do not message to everyone. Your time starts now. All right, guys, just a time check. Are we good to discuss? Does anyone need more time? Let me know. Anyone needs more time? Let me know. Are we good to discuss? We can discuss now. Quick with the chat, guys. Okay. So most of you said discuss. Let's start with the discussion. Cool. What did I talk about? We're going to talk about these 4 steps, how to implement these 4 steps. So we're going to focus on the template. So I'll take this part. 1, 2, 3, 4. I'll talk about it. We won't need the 4th one here, but let's list it down. Okay. So you will see how do you actually implement a template. Once you understand with couple of questions, maybe 2, 3 questions in beginning, you will feel confident to apply that. Now start with number 1. Step number 1 is how do we identify which problem statement can be solved by DP. We know the trick already. Can you look in this problem statement and tell me which line tells you it can be solved by DP? Look at this problem statement and tell me which line or which word or set of words tell you it can be solved by DP. Either this problem statement or this problem statement, however you want to implement it. Okay. If you look at this word, count the number of ways or count the number of distinct ways, whatever way it is implemented, that tells me very clearly it can be solved by DP. Step number 1, 33% of your problem is already solved. All agree? Step number 1 confirms it can be solved by DP. That's all you need. So 33% of your problem is already done within just 5 seconds, or how quickly you are with understanding the problem. Second, deciding a state expression. What did I tell you about? State of n will always be mentioned in the question. All you need to do is replace state of n with state of k. This is the trick. Okay. So state of n is what? Let's start with that. State of n is what I'm looking for is I want to know I can climb nth stair with 1 or 2 steps. So my state of n is this. Tell me the number of ways to go to the nth stair by climbing either 1 or 2 steps. So my state of n, number of ways to reach nth stair using 1 or 2 steps. Okay. Now what do I need to do? I just need to replace n with k. So this will become state of k. State of k will become number of ways to reach kth stair using 1 or 2 steps. Everyone crystal clear with this? Come on guys, quick in the chat. Any doubts, any questions, please let me know. State of n is already given in the question, which is what exactly I'm looking for state of n. I'm looking for number of ways to reach nth stair using 1 or 2 steps. So if I replace n with k, that will become number of ways to reach kth stair using 1 or 2 steps. Second part, everybody clear? Come on guys, quick in the chat. Cool. 10 seconds into the problem, 67% of the problem is already solved. 2/3 of the problem is already solved. Third part is the most important part. Formulate a state relation, identify how did you reach state of n to state of k. Okay. Why are we replacing n with k? To define the state of k. We define a state of k as random state k. That's why we're replacing n with k. Okay. Now, third part is the most important part, which is how do you formulate a state relation, right? If you're at k, how did you reach at the k in the first place? To understand that, let's understand the problem a bit more carefully. Imagine I want to reach at the 5th stair. Okay. If I want to reach at the 5th stair, what are the different ways I can reach to 5th stair? Quickly in the chat, guys. If I have to reach at the 5th stair, what are my entry point to which I can reach the 5th stair? There are only 2 entry points. Either I can go via 4th stair and take 1 step, or either I go by 3rd stair and take 2 steps. Is there any other entry point? Agree? There's no other entry point. These are the only entry point. Now, how do you determine this? The number of ways to reach fifth stair. Is this a AND condition or a OR condition? Is this a AND condition or OR condition? It's a OR condition. What do you mean by OR condition? Either I can go via fourth or I can go via third. I don't need to go with third and fourth. Either I can go via fourth or I can go via third. So this will become number of ways to reach fourth stair plus, which is a OR condition, number of ways to reach third stair. Plus represents my OR, multiplications represent my AND. Everyone crystal clear with this? Any doubt, any questions? All good? Cool. So can I write it like state of 5 as state of 4 plus state of 3? Yes or no? Okay. And if I have to further classify it, can I write it as, okay, one moment. Let's see. What is the third part is, the part 3 or the step 3 is just formulating a state relation. What does that mean? If you reach at a particular step k, how did you reach to the particular step k? Did you reach by k minus 1, k minus 2, etc., etc.? Basically, how is your current state result relating to the previous state results? Okay. Now, in this part, let's say I have to reach the fifth stair. How did I reach the fifth stair? Either I would have come from the fourth stair or I would have come from the third stair. There is no other way possible, correct? So if I write number of ways to reach fifth stair is either I can go by 4 or I can go by 3. It's not an AND condition, it's an OR condition. So I write it at number of ways to reach 4 plus number of ways to reach 3. So I've written it as state of 4 plus state of 3. Everybody clear now? Somebody asked for a follow-up. Are you clear now? Cool. So to your question, yes, it's a top-down. So state of 4 plus state of 3, I can write it as state of 5 minus 1 plus state of 5 minus 2. Yes or no? I'm able to reach at 5 because either I can take one step from 5 or two steps from 5. So 5 minus 1 plus 5 minus 2. All agree with this? Okay. If I extend this to state of k, this is just one example I've taken for fifth. But if I have to generalize it for a state of k, I would be able to write state of k minus 1 plus state of k minus 2. Everyone agree with this statement? This is your state relation. If you're at state of k, how are you at state of k? What are you relating with k minus 1, k minus 2, k minus 3, k minus 4, whatever it is? Have you seen this relation before? Have you seen this relation before? Correct. This is nothing. This is just a Fibonacci sequence. This entire question was Fibonacci sequence, nothing else. That is why I asked you in the beginning, do you remember or do you realize what pattern is this? Not many of people are able to read the problem statement and they can come up to the conclusion that this is a Fibonacci number. But once you have solved enough number of questions and you can look at the pattern, you can easily understand this is just a Fibonacci number. Okay. And to be very honest, you can do some cheat codes as well. What do you mean by cheat code? Look at the example input output. For first input, the output is 1. Second input, the output is 2. Third input, the output is 3. 1, 2, 3, 5. The sequence is going in Fibonacci. All agree? What I'm saying is input 1, output 1. Input 2, output 2. Input 3, output 3. Input 4, output 5. So even if you just observe the output, this is going in 1, 2, 3, 5. And next word will be 8. Next will be 13. Next will be 21. You could have figured out from here also. This is Fibonacci. All agree? But for that, you need to be very observant in reading the problem statement, looking at the sample input output. If you're sufficient enough, you don't even need to look at the problem statement, look at the output, what pattern it makes, start writing the code, submit it. Okay. Anyways, I would not recommend it in interview. I would recommend it in competitive programming contest when you are running against time. Anyways, everybody clear with this? Cool. Cool. If everybody's clear, we already know about the code part of it. Now, there is one thing I want to discuss, then I would move to the code part of it. So there was one line which was added in the problem statement, original problem statement, not in the lead code one, which was this one. Please output your modulus 10 to the power 9 plus 7. Can anyone tell me why this line was added? In the online assessment question, why this line was added? What's the purpose of this line? Come on, guys, quick in the chat. Shouldn't be this complicated. MLE. How is this related to memory? This is the answer to keep it within the range of integer. Okay. Let's say a very large answer, which might be out of range for all of this. In this range, the range is given only up to 45 numbers. The original ocean, it was not 45 numbers. It was up to 10 to the power 6. Might be out of range for integer. So if you take the modulus 10 to the power 9 plus 7, that gives you a very small number. Okay. A large number, modulus a large number is always a small number. Remember that. Okay. This is always going to be within range of integer. The whole purpose of modular arithmetic is built upon, the whole theory of modular arithmetic is built upon one fact. Large number modulus another large number gives you a small number. Okay. Example, 1000 modulus 999 is equal to 1. 1000 is a large number by itself. 999 is a large number by itself. But if you take the modulus, the output is only 1, which is very small number as compared to these two. Okay. Alright, guys, that being said, let's move on to the code part real quick. We already have seen the code of it. We will not be writing the Fibonacci, we will not be writing the recursive one. We will directly writing the DB one. So let's go to lead code. Let's look at the code. Let's start implementing the code. What do we need to implement? We are given the function integer climb stairs. We are given the integer n. First thing first, if n becomes 0, n become 1, n become 2, return n. Means for 0, the output is 0, 1, the output is 1, 2, the output is 2. Then I create integer stairs of n, stair of 0 initialized with 1, stair of 1 initialized with 2. For I equal to 2, I less than n, I plus plus. What I'm doing? Stairs of I equal to stairs of I minus 1 plus stairs of I minus 2. That's how I'm storing the state results. And then I return stairs of n minus 1. You can do it by n plus 1 also, then you can return n, or you can keep it n also, you can return n minus 1. Whatever you want to do. Both will work. Look at the code. Let me know anybody has any doubt, any questions. If you guys are clear, then we can move on to next question. Come on, guys, quick in the chat. Code is crystal clear to all. It's the same code that we have solved before. Okay. Why states of n? As I said, you want to keep 0-bit indexing. You can keep for n. If you want to keep 1-based indexing, you can keep n plus 1. I'm keeping 0-based indexing here. Okay. So states of n minus 1, that's why I create for the stairs n. So n minus 1 is representing for the nth stair. If you want to do it for n plus 1, you can do that also. Okay. All right. If you compile this, line 11, what's the issue with line 11? So line 11 is just a base condition. If I'm climbing 0 stairs, my number of ways is 0. If I'm climbing 1 stair, number of ways is 1. Climbing 2 stairs, number of ways is 2. So anyways, I'm initializing a value here, it will still get my answer. But if I can just eradicate in big O of 1, why do you want to calculate for big O of n? Okay. So I remove this part in big O of 1 itself. Okay. All right, guys, what's the time and space complexity? As you can see, time complexity is going to be big of n, 1 for loop. Space complexity is going to be big of n because we created this extra array. O in time, O in space. Let's compile this. Submit. Pass all test cases beat 100%, which we expected to. Point time, look at the space, big offense space. Okay. All right. If that is good, now let's move on to sublime text. What if one and two step is not mentioned and can take any number of steps within it? So any number of steps within n, then it will not become a DP question. It will become a backtracking question because technically we'll be exhausting all the possibility. Okay. We have a problem statement like that. We'll discuss that. Let's do this. Okay. All right. This was the code we just have submitted for and complexity big of n, space comp big of n. Okay. Let's move on to the next part. Before I move to the next question, sometimes a variation of this question is asked. Means, first of all, let me write it down. This is the same question as Fibonacci, first of all. Some variation of the question is asked in the sense, this problem was talking about you are standing at the bottom and you're climbing the stair. So you're taking one or two steps at a time. One moment, guys. If the problem statement changes that you're standing at the top of the stair and you're climbing down one or two steps, do you think the answer will change or will the answer remain same? Come on, guys, click in the chat. For loop. Mhm. The answer would be same. Either you're climbing up or you're climbing down, the answer would be same here. So maximum steps, either taking bottom to top, that is 0 to n, and same maximum steps, top to bottom, which is n to 0, is also going to be same, provided you're taking the same number of steps both times. Okay. So sometimes the variation also changes. To your question, how does an optimization over recursion? Same thing that we discussed in the Fibonacci part, 2 raised to power n to big of n. Okay. If you look at the recursive tree that you'll be creating for it, you will be having two branches to the raise of the depth n. Okay. All right. Let's move to second question. Second question is not on lead code, so I'll give you the problem statement and then we'll talk about one by one. This question was asked in Adobe. This was not asked in online assessment. This was asked in interview. Find the number of ways to make n as sum of 1, 2. Okay. Repetitions and combinations are allowed. Means what? I need to make n a number n using sum of only values 1 and 2. I can use them in any repetition and any combination. Okay. So if I talk about n equal to 5, the ways you can think is 1, 1, 1, 1, 2, 2, and all possible variations of 1 to 2. So this will be three permutations. 1, 2, 2 will become 2, 1, 2 or 2, 2, 1. Okay. What else? You can have 1, 1, 1, 2. And how many permutations will this have? Let's talk about it. Before that, hope everyone remembers basic permutation and combinations. Let's check it real quick. In case you miss any of the solution, you can quickly verify this answer with mathematical formula. If there are total n values, out of which r values are repeated, what is the total number of ways, permutations? Come on, guys, quickly in the chat. Out of n values, r values are repeated. What is the total number of permutations? Grade 11th permutation combination. R is the number of repeated values. N is the total number of values. Anybody else? Okay, I got a different answer. If C has to do anything with permutation, if C has to do anything with the permutation, C is for combination, guys. C is for selections. When you're talking about ways, it's permutation. When you're talking about selection, that is when you talk about combinations. Okay. The correct answer is n factorial by r factorial. This is the correct answer. So when you have to find the number of ways, you have total n values, r values are repeated, it's n factorial by r factorial. You can verify with any one of them. Let's quickly verify it. I have 5 values here. All 5 are repeated. So 5 factorial by 5 factorial, total ways will become what? 5 factorial divide by 5 factorial, it will be 1. So this is only counted as value. Okay. Look at second value. I have 3 total values. 2 values are repeated. So total number of ways would be what? 3 factorial divided by 2 factorial, that is going to be 3. So if you look at this, 1, 2, 3. This value, triple 1, 2. 4 values, 3 are repeated. So total ways are going to be 4 factorial divided by 3 factorial. So 4 factorial by 3 factorial will be 4. So you can make 4 permutations out of it. Okay. This is the mathematical way. That way you will never be able to miss anything. Even if you like list down all the solution, you're missing one thing, you will not be able to miss anything because you can validate by this. If you don't want to go by mathematical way, just use simple common sense. What do you mean by simple common sense? 3 values are repeated, 1 value is not. So what I can do is I can make 4 values or 4 ways by just moving 2 around. Agree? Simple common sense. If I have to make total number of ways can be made 4 only. Correct? So one way will be 2 here, one way will be 2 here, one way will be 2 here, one way will be 2 here. That's it. Okay. So let's write it down. Copy this, paste, paste, paste. So I'll move the 2 here. I'll move the 2 here. I'll move the 2 here. You can do it by mathematically, you can do it by without mathematically, however you want to do it. Output becomes 8. Okay. 4 plus 3 plus 1, output becomes 8. The function that you have to implement is integer solve, integer n is given, you have to turn integer as an output. Everybody crystal clear with the problem statement. A number n is given, you have to make it as a sum of 1 and 2 values. Repetitions and combinations are allowed. I've given you the sample input and output. Any doubt in the problem statement? Come on, guys, begin the chat. Any doubt in the problem statement? We'll discuss that, but problem is clear. Okay. Once the problem is clear, let's talk about the solution here. We'll take the 4 steps. Step of the templates. This part. Okay. Let's talk about the template part for this. Now, coming to it. Which part of the problem statement tells me it can be solved by DP? Look at the problem statement. Which keyword, set of keywords tells you it can be solved by DP? Correct. It very clearly says, find me the number of ways. So highlight this. It very clearly tells you this is solved by DP or can be solved by DP. Number of second part is deciding a state expression, state of n. What am I looking at state of n? Number of ways to make n as sum of 1, 2. That will be replaced to state of k. That will become number of ways to make k as sum of 1 and 2. Okay. State of n is always mentioned, replace n with k. That's what you'll get your answer for. Third, formulating a state relation. In terms of formulating a state relation here, let's talk about something. I'm only allowed to add one or two. Okay. So if I'm only allowed to add one or two, if I have to, let's say, make a number 7, in order to make 7, either I can add 1 to 6 or I can add 2 to 5. There is no other possibility which can exist. Agree? Quick in the chat, guys. So, number of ways to make 7 is what? Number of ways to make 6 plus, which is or, number of ways to make 5. So, state of 7 becomes state of 6 to the state of 5. Or I can further classify this as 7 minus 1 plus 7 minus 2. Or if I have to generalize it, I can say state of k is state of k minus 1 plus state of k minus 2. This is nothing but Fibonacci sequence again. Okay. It was the same problem that we have just solved. Okay. So you can put k minus 1 plus k minus 2. That becomes your state relation. And you can write the exact same code. It will pass all the test cases. Okay. Everybody clear with this problem statement? Cool. Microsoft asked the exact problem in a reverse way. So Adobe asked this question. Microsoft asked the exact question just in a reverse way. Let's look at that question also. The question was asked in Microsoft was this. Find number of ways to make n 20 by removing 1 and 2. So what you're doing this time is, again, repetition and combinations will allow. So repetitions and combinations are allowed. If n is given as 5, my output is still going to be 8. Okay. So either you do 0 to n as sum of 1 and 2, or you do n to 0 by removing 1, 2. Do you think there will be any difference? It will be exactly the same. Okay. So far, the question that we have discussed along with the variation, they are same. So these three guys, Fibonacci question, maximum steps, which is bottom to top or top to bottom, making a number n either by removing it or by adding it, still the same question. These all 5 questions are the same one, exact piece of code will work for all test cases. Everybody crystal clear with this. Okay. Put a little bit the memorization of question is, we can apply DP concept. Do you mean memorization instead of memorization? We'll see the question for memorization and tabulation. All of this, what we're doing is tabulation. We'll do one question for memorization also. Okay. It's quite late. We'll do it later. Clear any trick to write proper base case? Base case, we don't define base case in DP in general. Base case of the term is restricted to the recursion, right? And no such trick for the base case. You just need to talk about the edge cases, right? That's what becomes your base case. For example, in this case, my first value would be if I have to make 0 or if I have to make a value 1, I can take only 1 or 2 values. So the way that I can remove 1 to 0, it's going to be only one way. That becomes your base case here. Okay. All right, guys, we solved these 3 questions, which is technically all Fibonacci questions put in a different ways. Now we move to different question. And we move to different company. This question has been asked in PayPal. The question is removing chocolates. And for that, let's look at the problem statement exactly. Okay, we have more problem statement. Cool. This is the exact problem statement. Let's go through the problem statement. This was asked in online assessment. Let's go through the exact problem statement, then we'll talk about it. A box contains a number of chocolates that can only be removed one at a time or three at a time. How many ways the box can be emptied? The answer can be very large, so return it modulo 10 to the power 9 plus 7. For example, there are n equal to 7 chocolates initially, they can be removed 9 ways. So if you look at this, these are the 9 different ways they have listed. Input format represents a single line representing the number of chocolates in the box. Output format represents the number of ways of removing chocolates 10 to the power 9 plus 7. Constants are given up to 1 billion, which is 10 to the power 9. Sample input 1, 1. There is only one way to remove a chocolate, so 1 modulus 10 to the power 7, output becomes 1. Sample input 2, 3, the output is 2. So there are two ways to remove all the chocolates. So if you all remove all three at once or remove one after the other. So there are two ways to do that. 2 modulus 10 to the power 9 plus 7, again 2. The function that you have to implement is remove chocolates. Here you have to return the integer you have taken n as an input. This is the exact statement or exact problem statement which was asked in the online assessment. Everybody crystal clear with the problem first. Problem is clear to all. Any doubts, any questions? Okay, cool. If this is clear, first thing first, either I do n to 0 by removing 1 and 3, or if I do 0 to n by adding 1 and 3, are both the exact same questions? Agree? They both are exact same question. So if the variation is asked, technically it's the same question. Now coming to that part, there is some minor changes as compared to the Fibonacci that you need to write and solve for. I would recommend start solving this and we can verify your output. We are given the output like for n equal to 7, the output is going to be 9. Okay. So this is the function that you need to implement, pasting that in the chat. You guys can go ahead, start writing the code, and then let me know once you guys are done. Verify your output with n equal to 7, output should be 9. And base conditions like for 3, output should be 2, for 1, output should be 1. You're given 3 test cases in the question itself. Everybody crystal clear with the problem statement. Everybody crystal clear with the problem statement. Any doubt in the problem statement? All good? Okay. If you guys are good, start implementing the code. If you think that you are confident enough, share the code. We can test and submit it. Okay. Anyways, that being said, once you guys are done, then I'll start implementing via the template code. If you want to implement by template code, feel free to do that. No issues. This is fourth question we are solving, so you guys would become more comfortable now. Okay. Whoever feels confident that their code will pass all test cases, let me know in the chat. We can verify that. Okay. Do not forget to include the condition of 10 to the power 9 plus 7. Everyone is stay clear with the instruction, problem statement, function you have to complete. Anything which is not clear, please call it out before I give you your time. Okay. All right. If everything is good, you guys can start writing the code. Once you guys are done, share the link with me or share the code with me, then we can verify it. Okay. Do not forget the modulus part. Please change your message directly to me. Do not message to everyone. Once you guys are done, please call out for discussion. Then we'll start the discussion. Do not take more than 10 minutes. 10 minutes is higher. Do not take more than 5 to 6 minutes for this one. Your time starts now. Cool. Let's start the discussion now. I've seen majority of you have given the correct solution already, which is good. There is one tricky point in this solution that we need to discuss now. Let's follow the template real quick. We'll take the template here. There you go. Okay, let's start implementing. First thing first, what part of the problem statement identify this can be solved by DP? So if you look at the problem statement says how many ways the box can be emptied. So if you look at this, the box contains how many ways. This how many ways itself tells me this question can be solved by DP. Okay. So step number 1 or 1/3 of the problem statement is already done. Next, deciding a state expression. What is state expression here is if we talk about state of n, number of ways to remove n chocolates by removing 1 or 3 chocolate, right? Number of ways to remove n chocolates by removing 1 or 3 chocolates. If you replace by state of k, copy this, paste it here. Number of ways to remove k chocolates by removing 1 or 3. Step number 2 is also done. Now coming to step number 3. In step number 3, I think most of you would have already figured out, but let's take an example to figure that out in case anybody has not. If you have to, let's say, remove 7 chocolates, I'm taking one specific example and then we can generalize for the k value. If I have to remove 7 chocolates, what are the different ways? Either I can remove 1 chocolate and I will be back at 6, or I can remove 3 chocolates and then I will be at 4. So it would be something like this. From 7, you can go to either 6 or 4. Then from 6, you can go to 5 or 3. 4, you can go to maybe 3 or 1. Okay, that's it. Now, what do you mean by bottom up and top down? Let's write it down here. Bottom up approach means I can go 0 to n. By adding 1 and 3. And top down is what here? Top down means I can go to n to 0 by removing 1 and 3. That's it. N to 0 by removing 1 and 3. Okay. Alright guys, that being said, let's move on to the solution. So if at state of 7, if I write it as state of 6 plus state of 4, or technically I can write it as state of 7 minus 1 plus state of 7 minus 3. And if I have to generalize, I can say state of k would be state of k minus 1 plus k minus 3. All agree with this? Quickly in the chat, guys. All agree with this? Everybody would have figured out this state relation. Quick in the chat. Okay. Until this part, everything is same. You would have figured out it. Something which would change now is in terms of code. What exactly would change in terms of code? Let's talk about. There is a note to add here. Whenever you have k minus 1, k minus 2, k minus 3, k minus 5, anything, what you need to do is you need to find out, let's say if I have state of k defined as state of k minus 1 plus up to state of k minus p. And that p can be anything. P can be 2, 3, 4, 5, 10, whatever it is. Whenever you get such kind of a state relation where the maximum value is p, so in Fibonacci, p will be 2. You need to initialize your base cases first p values for your DP answer. Okay, this is a thumb rule. In your state relation, whatever is the maximum value which is given, you need to initialize till that value. So if p become 10, I need to initialize the first 10 values. If p become 5, I need to initialize first 5 values. Okay. Example. Your state of k, when it was k minus 1 plus k minus 2. If you remember, what we did was we initialize first 2 values for DP answer. Okay. Similarly, in this question, I have for k minus 3. So how many values I need to initialize? Click in the chat, guys. I would need to initialize first 3 values. If it was 5, I would initialize first 5 values, n values, so on and so forth. So I have to initialize first 3 values. Let's talk about it. What will be the 3 values? DP of 1. What are the different ways to make 1? It's only 1. So 1. DP of 2. What are different ways to make 2? I can use only 1. So again, output 1. DP of 3. What are different ways to make 3? Either you can use 1, 1, 1, or you can use 3. So DP of 3 will become 2. All agree with this? 1, 1, 2. These are the initial values that we need to initialize with. Okay. Okay. If everybody's clear, let's quickly write down the code for it, and that should do the job. The function that we have to complete is remove chocolates, which is this integer n. Let's implement this function real quick. Okay. The only tricky part of this question was figuring out how many state variables you need to, or how many base conditions you need to write. So base condition is dependent upon your state function, and state function says maximum value 3. So you need to initialize till 3. Okay. So integer answer, new integer n, answer of 0, make it 1, copy this, paste, answer of 1, again make it 1, answer of 2, now you make it 2. Okay. You need to take modulus. Let's define modulus. 10 is to the power 9 plus 7. You can write 1 in 9 plus 7 as well. Now what you do? For integer I equal to 3, I less than n, I plus plus. What do we need to do? Answer of I is equal to answer of I minus 1 plus answer of I minus 3. Okay. And then I can return answer of n minus 1. This is before implementing the mode. If you want to implement the mode, how would you implement the mode? Okay, this part. Time complexity, big of n, space empty, big of n. Everybody is still clear with this code, then I have one optimization to share. But everybody is still clear with this code. Come on guys, put in the chat. Everybody is still clear with this code. Okay. It will add more at every iteration. Yes, it will. Okay. All right. This was a problem statement which was asked in online assessment for PayPal. Very good problem statement. I mean, you just need to identify so a couple of things one by one. Couple of things. First things first, you need to identify why it's a DP based question if you go by the template. Second, deciding the state expression and formulating a state relation. Till so far, we have already done 3 to 4 questions before, so now we are familiar. The important part here is since it is k minus 3, or since it is taking for 3 chocolates, I need to initialize the first 3 values. That's why I initialize the first 3 values here. Okay. Answer of 0 equal to 1 because I'm basing 0 base indexing. So answer of 0 is technically representing 1. Answer of 1 is representing 2. Answer of 2 is representing 3. So if I have to remove 1 chocolate, 1 way, 2 chocolate, 1 way, 3 chocolate, 2 ways. That's what is 0 base indexing. You want to keep 1 base indexing, you can do that also. Okay. That's why n minus 1 is technically representing nth chocolate, or number of ways to remove n chocolates, technically. Okay. All right, guys. Everybody crystal clear now? Question, code, approach, time and space complexity, everything clear? I just explained the same thing, guys. So we are taking 0 base indexing. So that is why answer of 0 is 1. Answer of 0 is representing 1 here. So this is number of ways to remove 1 chocolate. Okay. All right. Mod iteration versus primordial n minus 1. Does that make any difference? We'll talk about it. Well, even if you implement here, doesn't make any difference because you already implemented the mode here. So there's no point of implementing it. Okay. All right. Coming back to it. Question clear, code clear, approach clear, time and space complexity clear. Okay. What if I tell you that this code will still not pass all test cases? There is something which is still missing in this code. Can anybody figure out what that is? This code will still not pass all the test cases. Can anyone figure out what is missing in this code? 10 seconds, guys. Less than 1 and 3. Less than 1 and 3 means a number of chocolates cannot be less than 1, right? There cannot be negative chocolates. There cannot be 0 chocolates. Anybody else? Okay, never mind. See, from a DP perspective, if it's memory limit as you can't assign one line, no, you can assign. This code will work. Don't worry about it. So from a DP perspective, nothing is missing here. From DP perspective, everything is covered. It will pass all the test cases. What is missing is from the modular arithmetic perspective. So if you don't know it, you would never able to figure out. If you know it, only then you can understand what is wrong with this line number 680. And this is technically more part of CP as compared to DSA because these are more critical ticks that you have used by CP, right? But I'll tell you right now what is problem here. This will be able to pass maybe 80% of the solution. I have not tried submitting it, but will not pass 100% of the submission. Okay. And those pending 20% of the submission, that will require some advanced skills. What is that advanced skill? Let's talk about it. A plus B mod M is same as A mod M plus B mod M and whole mod M. This is modular arithmetic. Okay. A plus B mod M is A mod M, B mod M, whole mod M. Now the question becomes, if there is an equality, means LHS is going to be RHS. Why we have to refer to this one, why we have to refer to that one? First, let me prove that and then I'll come back to this. A equal to 23, B equal to 25, C equal to 10. You can take any three random numbers. You can verify by yourself. Okay, let's calculate LHS. Let's calculate RHS. So you're confident that it is actually an equality. If I calculate LHS, which is A plus B mod M, that is going to be 23 plus 25 modulus 10. So 48 modulus 10. What is the output? Output is 8. Okay. RHS part. A modulus M, B modulus M, whole modulus M. So A modulus M means 23 modulus 10. B modulus M means 25 modulus 10. And then whole modulus 10. So that becomes 3 plus 5, 8 modulus 10. That becomes 8. Is my LHS equal to RHS? Yes or no? Quickly in the chat, guys. LHS equal to RHS. You can take any three random values for A, B, and M. You can verify by yourself. It will always work. But the question becomes, is there any difference in using this versus using this? The answer is yes, there is a difference. Your LHS can lead to overflow. RHS will never lead to overflow. Okay, take an example to understand. This is verification. This is verification. Okay, take an example to understand that. If I say A equal to 1.1 billion and let's say B equal to 1.1 billion. If you take the LHS part will say 2.2 billion, or let's write it here, A plus B modulus M. The moment you are doing A plus B modulus M, first you will do A plus B and then you will do modulus M. Agree? First you will do A plus B, then you will do modulus M. The moment you have done A plus B, this has become 2.2 billion. Now you're doing a modulus of whatever the M value is given. 2.2 billion is greater than range of integer. The moment it goes beyond the range of integer, it's going to turn into a negative value. So your answer will be inaccurate. Whatever you're taking is on an incorrect number. So this will be some large garbage value / negative value modulus M. This part clear? On the same side, if you talk about RHS, what RHS claim? A modulus M, B modulus M, whole modulus M. A is less than 2 billion or range of integer. B is less than range of integer, and eventually it's going to be very small value. So A modulus M within range of integer, B modulus M within range of integer. Hence, the final answer remains within range of integer. Okay. This is the trick of modular arithmetic. We'll discuss more in modular arithmetic if we get time. But just to tell you, these are some of the CP tricks that if you don't know, you don't know, right? You will not be able to figure out what is wrong in this code unless you have implemented this or unless you know about this. Okay. So the right way where it will pass all test cases is this. A modulus M, B modulus M, then whole modulus M. Now this will pass all the test cases. Okay. All right, guys. Everybody crystal clear with this? Everybody crystal clear with this? Quick in the chat. Okay. All right. Let me answer some of the question in the chat. Doing addition further can it overflow? I was thinking, but answer -1 can answer -3 can be more M in our case, right? Answer I-1 and answer I-3 can be more than M in our case. Yes, it can be. That's the whole idea. These values can be very large, right? So they become large enough, and if you implement the previous solution, they will give you overflow. A1 means 2 chocolates. How A1 equal to 1? A1 means 2 chocolate. What is A1? You mean answer of 1? Answer of 1 means 2 chocolates. Yes, the answer is 1. So for 2 chocolates, the answer is only 1 because you guys use only 1 chocolate or 3 chocolate at a time. So there is no 2 chocolate that you can remove. So if you have to remove 2 chocolates, you have to remove 1 comma 1. Only one way. That's why it is 1. Okay. In our question, it won't, I assume. In our question, it won't, I assume. It will not go to overflow. It can go to overflow. It can. Okay. But a previously calculated answer, I-3 and I-1 will already be in the range of 0 to n. I-3 comma I-1 modulus n. So what you're calculating is you're calculating their sum and you're assigning to answer of 5. This answer of 5 can become negative, right? That's what we're doing. So understand this. The moment I-1, I-3 becomes large enough, and then you take a more on top of it, that's when it can become negative. Okay. All right. And 10 to the power 9 plus 7, even if you take like, let's say, it can be between the range of 0 to m. So let's say even if it goes m both cases, that will still give you overflow. Number where can be large values depend on n. Yes. L will be 10 to the power 9. Constant is given already in the question. This is online assessment. So 100, yeah, this is given here. It's always given. Okay. All right, guys. Question number 4. Everybody crystal clear? Then we can move to question number 5. All good? Good. Let's move on to question number 5. It's a variation of this, and we can solve this question before wrapping it up for sure. Question number 5 is which is asked in Microsoft. Again, a variation of this problem. The variation is now you're given set of values. You're given 3 values, 1, 3, and 5. The problem statement is you're given 3 numbers. Let me find the exact problem statement. It will save me time writing. This is the exact problem statement. Given 3 numbers, 1, 3, and 5, count the total number of ways to form a number n using sum of these 3 numbers, 1, 3, and 5. Repetitions and combinations are allowed. For example, for input 6, the expected output is 8. So if you look at this, one way for this, and this is 4 values repeated. So 4 factorial by 3 factorial, 4 ways out of this. And this is 3, 3, 5, 1, 1, 5. Total ways are going to be 8. Variation can be asked if you have to make n to 0 by removing 1, 3, and 5. Both are going to be same. The function you have to complete is count ways integer n is given to you. Everybody crystal clear with this. Variation of the question of PayPal has been asked in Microsoft. Instead of 2 values, now they have asked for 3 values. You're given 3 values, 1, 3, and 5. You need to count with the total number of ways to form a number n using some of these 3 numbers. Any doubt in the problem statement? Let me know. Come on, guys, put in the chat. problem is clear? Okay. If problem is clear, let me give you the function that you have to implement. You guys know the drill. Start implementing the code, follow the template, let me know the answer. Once you guys are done, ready to discuss, let's quickly discuss this. We should be able to finish this question before wrapping up today's session. Okay. I'm giving you 5 to 6 minutes. Complete the solution. You can verify with the input. 6 output should be 8. And I can give you a few more test cases if you want to verify it. Okay. All right, guys. Solve this question. Let me know once you're good. Then we can move on to the template part of it or discussion part of it. Okay. I'm giving this problem statement as well in case you want to check that. Once you guys are done, please let me know in the chat. We'll have a discussion. Your time starts now. Please change your message directly to me. All right. Cool. Are we good to discuss now? Just let me know in the chat. Anyone needs more time, please let me know. Cool. Let's start this discussion, guys. It will take time us to reach the code part. Let's start the discussion for the template. Okay. So let's take the template back. This part. Cool. The only tricky part of this question, since it is given as 1, 3, and 5, what we need to do is we need to make it till first 5 numbers. Okay, 1, 3, and 5. Now, coming to first, count the total number of ways makes it very clear. It's a DP question. Take this part, put the count the total number of ways. There you go. Okay. Second, deciding a state expression. Number of ways to make n as using sum of 1, 3, and 5. That is going to be your state of n. Copy this, replace with k, becomes state of k. Make k using sum of 1, 3, and 5, that becomes state of k. Okay. Formatting a state relation, this is important here. So what is going to be the state relation here? You can quickly see, if I have to make 7 here, the ways to make 7 using 1, 3, and 5 is I can add 1 to 6 to make it 7. I can add 3 to it to make it 7. Or I can add 5 to it to make it 7. Okay. Similar, but not exactly same. So my ways become what? My ways become in terms of T diagram. From 7, I can go to 6, I can go to 4, I can go to 2. Okay. So state of 7 would be sum of state of 6 plus state of 4 plus state of 2. Another way of writing it is state of 7 minus 1 plus state of 7 minus 3 plus state of 7 minus 5. Okay. So if you have to generalize it, state of k would become state of k minus 1 plus k minus 3 plus k minus 5. Okay. Now, if you implement it by recursion, so complexity of recursion now. Branches raised to the power depth. So branches raised to the power depth. What will happen in this case? My recursive code will go to 3 branches raised to the power n depth. And my DP code will be big of n. Okay. This would definitely lead you to TLE and this would pass all test cases. Okay. Now, next thing is we have a maximum value of 5. So if you're given a maximum value of 5, what do I need to do? I need to initialize till 5 values. Okay. If you have to initialize till 5 values, what do we need to do? Let's go till first 5 values. If we have to make 1, this is your answer. One moment, guys. Answer becomes this, k minus 1, k minus 3, k minus 5. Cool. It array size is 5, then time constant 5 is the power n. Not array size 5, it depends on the structure of the tree. The structure of tree, there's going to be 3 branches, then 3 raised to the power n branches, and raised to the power n. Okay. All right. If you have to make 1, there's only going to be one way. If I have to, let's write down the base cases real quick. If you have to make 2, how many ways? Make 3, how many ways? Make 4 how many ways? Make 5 how many ways? Quickly let me know in the chat. So 1 is going to be one way. If I have to make 2, again going to be one way because what am I using? I'm using 1, 3, and 5. Okay. If you have to make 3, how many ways are there? You can use 1, comma 1, comma 1, or you can directly use 3. So technically there are 2 ways. If I have to make 4, 1, comma 1, comma 1, comma 1, and 1, 3, and 3, 1. So 3 ways. Okay. And similarly, if you talk about 5, so 1, 2, 3, 4, 5, 1, 1, 3, 1, 3, 1, 3, 1, 1. Okay. And 5. So 1, 2, 3, 4, 5 ways. Everyone crystal clear with the base cases. Anybody has any doubt, any question, let me know. Okay. Everyone crystal clear with these cases? Okay. If this is clear, now I think we can move to the code part real quick. Shouldn't take much time for it. The function that you need to implement is this integer count ways. You're returning an integer, taking an integer. What do you need to do? Define your result equal to new integer n plus 1. If you want to define with n, you can go ahead with that also. Okay. So my result of I would be number of ways to make I. Zero based indexing, one based indexing, completely up to you, however you want to implement. The previous two questions, I implemented zero based indexing. So that's why I'm implementing one based indexing here. So my base cases would be what? Result of 1 should be 1. Copy this, paste, paste, paste. 2, 3, 4, 5. So 1, 1, 2, 3, 5. 1, 1, 2, 3, 5. Okay. Now I start with the loop for I equal to 6, I less than equal to n, I plus plus. What do you need to do? The result of I is going to be result of I minus 1 plus I minus 3 plus I minus 5. Okay. And then you return result of n. Time complexity, big of n, space complexity, also big of n. All agree with this? What if the input given is many instead of less numbers like 1, 3, and 5? How do you define the base case? That's some question somebody has asked it before. If you're given an n range of values, right? If it's a limited number of values, you have to still follow the same format. But if you're given like n range, you can use anything between 1 to n. That will become more of a backtracking question rather than the DP question. Okay. And indexing should be 0, right? So for loop should start from I equal to 5. We can start from 6 itself, right? Because till 5 part we already initialized. Till first 5 we already initialized. So if I start with 6, 6 minus 5, which is 1, which is present here. That's fine. Okay. That's why I said you want to keep 0 based indexing, you can. You want to keep 1 based indexing, you can. Okay. The previous two solution we did 0 based indexing. That's why it was n here. You can do n and n minus 1 here as well. Okay. Alright guys, let's quickly verify whether our code is correct or not. So if n equal to 6, we know the output is 8. Let's verify that. So in our code, we are saying that result of 6 is going to be result of 5 plus result of 3 plus result of 1. Result of 5 was what? Result of 5 was, as we calculated, 5. Result of 3, what we calculated, 2. Result of 1 we calculated was 1. So 5 plus 2 plus 1, that is correct. And that is equal to your output as well. Means it's working completely fine. Okay. Alright guys, let's wrap up the session here for today. Let's quickly revise what you've done as part of today's session, then we'll do. Y exactly 10 to the power 9 plus 7. There is no reason that y exactly 10 to the power 9 plus 7, and does not need to be exactly 10 to the power 9 plus 7. The idea is whenever using modulus, you take extremely large value and ideally a prime value. Okay. So when you take modulus, you're not left with n remainders. Okay. 10 is to the power 9 plus 7 is a very commonly used in problem statement, but it's not a guarantee that in every problem statement is going to be exactly 10 is to the power 9 plus 7. It can be any other big value also. Okay. The preference is large value, which is prime. All right. Coming to it real quick. We continue with our DP session, and in second session, we have completed 4 or 5 questions as well, which is good. We'll continue with the more questions in our next session. The most important, the crux part of the DP was this. We have to come up with a template which lists down 4 steps how you can solve any DP question in the world. We talked about step 1. How do you identify whether the question can be solved by DP or not? You look at the keywords. Keywords will tell you whether it can be solved by DP or not. Okay. This is the trick. This is the reasoning behind it. Explain that in detail. Then we move to second part. Once you have identified the question can be solved by DP, then you move to state expression. What exactly is state expression? State of n is always given in the question. State of k is what you have to find. So at a state of k, what exactly I'm looking for? So the trick for that is you replace n with k. Third is formulating a state relation. This is the most important part of solving a DP problem. If you're at state of k, how did you reach at state of k? Coming from k minus 1, k minus 2, or maybe something else. So how does your current state result relates to the previous results? And fourth is for the optimization, either implement via tabulation, memorization for higher order DPs. We start with the questions here. Let's start with question number 1, which was asked in Amazon, maximum steps to reach nth stair. The same question is available in LeetCode as well as climbing stairs. So we followed with the template. Number 1, we identified it's actually a DP problem. We identified the state of k, where we have to reach at kth state using 1 or 2 steps. We formulate the state relationship to understand how the state relation looks like. Once we identified the state relation, we come to the conclusion this is just a Fibonacci question, which we could have also understood by the input-output format. Okay. Fibonacci code we have already seen through. So we write down this code on LeetCode. We verify it passes all test cases, on time, on space. Same question would be if it has to turn from n to 0. Then you move to question number 2, which has been asked in Adobe, which is find number of ways to make n as sum of 1 and 2. We still did the same format and following the template. We talked about step number 1, step number 2, step number 3. Step number 3 comes out to be same as Fibonacci. So if you look at this is also going to be a Fibonacci question. Variation of this has been asked in Microsoft, which is question number 3. If you have to make n to 0 by removing 1 and 2. So all these 5 questions are technically the same question. Then you move to question number 4, which is a different question by removing chocolates. This time I'm removing 1 or 3 at a time. Okay. So when you're removing 1 or 3 at a time, obviously either by removing 1 or 3 or adding 1 or 3, they are going to be a green same question. We follow the template, we identified it's a DP question, we decide the state expression, then we move formulate a state relation. The tricky part here is once you got k minus 1, k minus 3, whenever it is k minus p, you need to initialize the first p value. So in this case, I will need to initialize the first 3 values. So when you initialize the first 3 values, we write down the code. Second thing to take care is in terms of modulus. If you have to pass all the test cases or you have to take care of all the edge cases, you have to use the right set of modulus. So a bit of model arithmetics here, which we'll discuss later as well. LHS will not give you overflow, LHS will give you overflow, RHS will not give you overflow. That's why we implemented with the RHS solution. Okay, answer would be same. Then we move to question number 5, which is again asked in Microsoft, variation of sum of numbers, which is 1, 3, 5. So this time we got 1, 3, and 5. So we verified with the template, step number 1, step number 2, step number 3. Since my state relation contains 5, I need to initialize the first 5 values. So we initialize the first 5 values, we write down the code, we verified our output as well. Time constant big of n, space big of n. So we have solved 5 questions today on DP. Okay. Everybody crystal clear with this? Quickly give me clear on the chat. Everybody crystal clear with this? Okay. Which is better, top down or bottom up? When we'll discuss top down, bottom up, that is when we'll discuss more about it. Okay. In general, top down is easier to implement. Bottom up is fine to implement, but top down is what most of the people prefer. Okay. But again, it depends on question to question. All right, guys, that being said, let's wrap up the session here for today. I know we extended the class for 20 minutes. I don't want to hold on for more. We'll resume with this pending question that we have on DP, and then we'll move on to the 2D DP. Thanks for joining in, guys. Let's wrap up the session here for today. Let's catch up in the next class. We'll continue from there. Thanks for joining in. Have a good day.